Hello everyone, today we want to learn about the Newton-Raphson method, which is a powerful numerical technique for finding roots of equations. This method is widely used in science and engineering due to its efficiency and fast convergence. By the end of this tutorial, you will understand the concept behind the Newton-Raphson method, learn how to derive the formula, apply the method through step-by-step examples. So, first we want to understand the concept. Newton-Raphson method is an iterative numerical method which is used to find approximate roots of the function. It works by improving guesses iteratively using derivatives. Imagine you have the function of f of x and you want to find the roots of this x. The root is the point that the f of x would be equal to 0. And we want to find this root using an approximation method, a numerical method, which is called Newton-Raphson. Instead of solving this equation algebraically, we want to use tangent line at an initial guess to approximate the root. The intersection of the tangent with the x-axis gives us the better approximation for our next guesses. In order to understand this concept better, I'm gonna use a visualization graph to actually graph and draw the function of f of x. Then I'm gonna proceed how we can find the approximation of the root using this method. So let's assume that we have this axis, which the y is f of x and the x-axis is x, and our function is looking like this, which this point, which I'm marking with the black point, is the root of the function which we want to find. So as I mentioned, we are first gonna take an initial guess such as x 0. This would be our initial guess, and we are hoping that x0 is the actual root of the function. When we put x0 into the function, we would get f of x0, which this value, as it is obvious on the graph as well, is not equal to 0. So that means x0, which was our initial guess, is not the correct guess and is not the correct root for the formula. So we have to take another guess, and we actually have to iterate this formula in order to find the final root of the function. So our second guess would be the intersection of the tangent line at x0 with the x-axis. So if we actually draw the tangent line at x0, it would be intersecting with the x-axis at this point, which I'm gonna label this point now x1. So as you guys see in here, our new intersection, which is called x1, is now closer to the actual root. And if I repeat this process over and over again, we are finally gonna get closer to the root of the function. So let's say that at x1, the value for the function would be f of x1. Now, if I actually draw another tangent line at x1 and intersect it with the x-axis, it would be this line, which has an intersection with the x-axis, and I'm gonna label this one x2. which this point is now more closer to the black point, which is the root of the function. And I'm gonna find the y value for x2 as well, which would be f of x2. As it is visible in here, we are getting closer to root based off the fact that we are using tangent line for our guesses. Okay, now in order to drive the formula for Newton-Raphson method, we're gonna calculate the slope of each tangent line, and based off that, the Newton-Raphson formula would be extracted. So, we are gonna first calculate the slope for the red tangent line. We're gonna call the slope m, which would be equal to f prime of x at the given point, which is x0, would be equal to the ratio of the vertical change to the horizontal change at two given points, which on the red line, as you see here, we have these 2 points, which the vertical change would be equal to f of x0 minus 0, and the horizontal change would be x0 minus x1. If you rearrange this equation, you would get that x1 is equal to x0 minus f of x0 divided by f prime of x0. Now we are gonna do the same for the purple tangent line. The purple tangent line, we're gonna name the slope again with m, and the slope of the tangent would be the f prime of x at the given point, which is x1 in here. This one would be equal to, again, the vertical change, the ratio of the vertical change to the horizontal change at two given points. As you see in here, the 2 points in here are these 2 purple dots in here. So the vertical change would be equal to f of x1 minus 0, and the horizontal change would be equal to x1 minus x2. And if you rearrange this equation again, it would get you to x2 is equal to x1 minus f of x1 f prime of x1. And if you continue drawing the tangent lines, you can get these equations. Based off these equations, we can make a conclusion that in general, x of n plus 1 is equal to xn minus f of xn divided by f prime at xn. And this would be the general formula for the Newton-Raphson method. Okay, now in order to understand the formula better, we're gonna solve an example and apply the method to find the roots of the equation. Let's say that, for example, we have this equation f of x is equal to x squared minus 4. And we want to find the roots of this equation based off Newton-Raphson method between the intervals that x is from 1 to 5. So what we would need for the Newton-Raphson formula is, first we want to have f prime of x and derivative of it. It would be equal to 2x in this case. And we also want to have an initial guess. Our initial guess, for example, would be 3. We can also solve this question using another initial guess and compare your answers to mine. So after we got the initial guess and we got the f prime, we are ready to calculate our x1. which would be our second guess. So x1 based off the formula would be equal to x0 minus fx0 and f prime of x0, which would be equal to 3 minus f prime of x0 is just substituting the 3 value in the equation. It would be 3 squared minus 4 divided by f prime of x0, which would be 2 times 3, which would get us to x1 would be equal to 2.1667. After we got the x1 value, we need to repeat the process and move another step further. So now we want to calculate x2 based off the value of x1 that we already got. x2 would be equal to x1 minus f of x1 divided by f prime x1, which would eventually give you 2.166 minus 2.167 to the power of 2 minus 4. We just substituted this value of x1 into our f of x divided by 2 times 2 point, which would get us the value of 2.0064. We should actually continue calculating x values and actually calculating more guesses until we see convergence in our answer. So we would actually get the same value if we continue calculating more x's. So if we do the same for x3, we would get x2 minus f of x2 divided by f divided by f prime of x2, which would get us to 2.00001. As you guys see in here, we are getting close and more close to the value of 2. So, and if you continue calculating x values and calculating more guesses, you will eventually see that our answer become convergent at x equals to 2. So we can say that the root of the function is equal to 2.